Q6699-2. What should help prevent aircraft-induced oscillation on a gyroplane? A. Adding a horizontal stabilizer. B. Increasing cyclic control sensitivity. C. Lowering the center of gravity below the thrust line. The correct answer is A. To prevent aircraft-induced oscillation on a gyroplane, adding a horizontal stabilizer is the most effective measure. Here's the reasoning in detail. Aircraft-induced oscillation refers to the tendency of an aircraft, including a gyroplane, to oscillate uncontrollably in pitch, roll, or yaw motions. This can occur due to various factors such as aerodynamic instability, improper control inputs, or insufficient stability augmentation systems. Adding a horizontal stabilizer is a solution specifically aimed at addressing pitch stability. The horizontal stabilizer is a fixed surface located at the rear of the aircraft, typically horizontal to the flight path. Its primary function is to provide stability in pitch, resisting changes in the aircraft's pitch attitude. By adding a horizontal stabilizer, the gyroplane gains improved pitch stability. It helps to maintain the desired pitch attitude during normal flight and reduces the tendency for abrupt pitch changes or oscillations. The stabilizer achieves this by generating a stabilizing force that counters the pitch moments created by other aerodynamic forces. The stabilizing effect of the horizontal stabilizer enhances the overall stability of the gyroplane, making it less prone to aircraft-induced oscillations. It provides a level of stability that helps the aircraft maintain its desired flight path, especially during various flight conditions and maneuvers. 7093-1. Which statement is true concerning a gyroplane? A. Rotor RPM will remain constant during changes in airspeed while descending. B. A gyroplane is capable of getting into a settling with power situation much the same way as a helicopter. C. A gyroplane can safely descend vertically or move backward with respect to ground references during a descent if altitude permits. The correct answer is C. The correct statement concerning a gyroplane is that it can safely descend vertically or move backward with respect to ground references during a descent if altitude permits. This is because of the unique characteristic of gyroplanes called autorotation, where the rotor spins freely due to the airflow passing through it. During a descent in a gyroplane, the pilot can adjust the flight controls to maintain a vertical descent or even move backward relative to the ground. The rotor's autorotation allows it to continue generating lift without relying on engine power. As long as there is sufficient altitude to accommodate the descent and the pilot maintains control of the aircraft, these maneuvers can be performed safely. This capability of descending vertically or moving backward during a descent can be useful in certain situations, such as landing in confined spaces or maneuvering in tight areas. However, it's important for the pilot to consider altitude, wind conditions, and other factors to ensure safe flight operations. In summary, the correct statement is that a gyroplane can safely descend vertically or move backward with respect to ground references during a descent if altitude permits. This is made possible by the gyroplane's autorotative rotor system, which allows it to maintain lift without engine power. 7093-2. Which is true concerning operation of a gyroplane? A. Like a helicopter, vertical descents to a safe landing are possible. B. Altitude permitting, flying behind the power curve is not a problem. C. Rotor RPM remains constant during changes in airspeed while descending. The correct answer is B. Certainly. Here's the reasoning in detail without mentioning the incorrect options. The correct statement concerning the operation of a gyroplane is that altitude permitting, flying behind the power curve is not a problem. Flying behind the power curve refers to a situation where the aircraft's airspeed is below the minimum power-required airspeed. In this situation, the aircraft requires a higher power setting to maintain level flight. This can be a concern for aircraft as it may limit the available power for maneuvering or climbing. In the case of a gyroplane, however, flying behind the power curve is not a significant problem provided there is sufficient altitude. This is because gyroplanes have the ability to enter autorotation, where the rotor continues to rotate and produce lift even without engine power. During a descent, the pilot can reduce engine power or enter a glide, and the rotor will continue to generate lift as long as there is sufficient forward airspeed. Altitude permitting, the gyroplane can safely fly at airspeeds below the minimum power required airspeed without experiencing a significant loss of performance or control. This flexibility allows for various flight maneuvers and descents, including vertical descents to a safe landing, similar to helicopters. In summary, the correct statement is that altitude permitting, flying behind the power curve is not a problem in the operation of a gyroplane. This is due to the gyroplane's ability to enter autorotation and maintain lift even without engine power, allowing for safe descents and maneuvering at airspeeds below the minimum power required airspeed. 7095. In which takeoff situation would a gyroplane with jump takeoff capability have an advantage? A. Soft field. B. Short field. C. High elevation. The correct answer is A. A gyroplane with jump takeoff capability would have an advantage in a soft field takeoff situation. Soft field takeoffs typically occur when the runway or takeoff surface is covered with loose or soft materials such as grass, sand, or snow. In these conditions, conventional aircraft may encounter difficulties due to the increased drag and potential for getting stuck or bogged down. A gyroplane with jump takeoff capability is designed to overcome these challenges. Jump takeoff refers to the technique where the gyroplane initiates the takeoff roll at a higher speed than normal, allowing the rotor to generate additional lift. This higher lift helps to reduce the ground roll and minimize the effects of soft or uneven surfaces. By utilizing the jump takeoff capability, the gyroplane can accelerate to a higher speed before lifting off the ground, effectively reducing the time it spends in contact with the soft surface. This helps to mitigate the effects of drag and increases the likelihood of a successful takeoff without getting bogged down. In summary, a gyroplane with jump takeoff capability would have an advantage in a soft field takeoff situation. The ability to generate additional lift during the takeoff roll allows the gyroplane to overcome the challenges posed by soft or uneven surfaces, reducing the risk of getting stuck or encountering excessive drag. 7097-1. Rotor torque is a concern in gyroplanes only during A. Prerotation or clutch engagement. B. Maneuvers requiring high rotor RPM. C. Maximum performance climbs and go-arounds requiring higher engine RPM. The correct answer is A. Rotor torque is a concern in gyroplanes only during prerotation or clutch engagement. During the prerotation phase, or when the clutch is engaged in a gyroplane, the rotor is accelerated to its operational RPM. At this point, the engine power is transferred to the rotor system, causing it to rotate. As the rotor spins, it generates torque due to the reaction of the rotor blades pushing against the surrounding air. The torque generated by the rotor can have an effect on the gyroplane's stability and control. If not properly managed, the torque can cause the gyroplane to yaw or rotate in the opposite direction of the rotor's rotation. To counteract this torque effect, gyroplanes are equipped with anti-torque pedals. These pedals allow the pilot to vary the pitch of the tail rotor blades, which in turn generates a counteracting force to counteract the rotor torque. During other phases of flight, such as maneuvers requiring high rotor RPM or maximum performance climbs and go-arounds, rotor torque is not a significant concern. These maneuvers may require higher engine RPM or increased power, but the rotor torque is typically managed through the use of the anti-torque pedals. In summary, rotor torque is a concern in gyroplanes only during prerotation or clutch engagement. It is during these specific phases that the rotor torque effect needs to be properly managed using the anti-torque pedals to ensure the gyroplane's stability and control.